Chapter 4, Transmitting Signals. One portion of the Federal Communication Commission exam deals with emissions. Emissions are simply radio signals transmitted from a station. This includes signals you intend to transmit as well as those you don't. Undesired signals are called spurious emissions. Spurious emissions is usually defined as a signal generated radiated by the equipment system, or those signals intended to generate radiated generally if they operate in specific frequency with no signals over the other point electromagnetic spectrum are being radiated to by your equipment power lead transmission lines antenna system. Federal Communication Commission rules spurious radiation amateur stations shall be produced eliminated in accordance with good engineering practice. It's sometimes difficult to eliminate spurious signals. Rules state with the radiation present shall not be sufficient intensity to cause interference with receiving equipment. Good engineering design and adequate selectivity characteristics, which are tune frequency, output, frequency band employed by amateur station. There's several different classifications of emission. Each emission has been assigned to a code. Now, licenses are permitted to use only one class emission A. The A refers to type of modulation, which is amplitude by 1, refers to the type of the transistor with a telegraphed on and off key without using modulating audio. Frequency table 4.1 identifies different types of emission codes. Last question is a section typical of the question can be found in the Federal Communication Exam. Alright, A1, telegraphing uses modulating audio frequency on-off key, desired carry key. T2, on carry amplitude modulating audio frequency and off-key modulated emissions. A3, radio telephone. A4, fast mile. A5, television. F1, telefrequency shifting using modulation audio frequency. F2, on-off frequency modulating audio frequency on-off key speaking modulated special case on-key emission frequency. F3, radio telephone. F4, fast mile. F5, television, and P for pulse. What are spurious emissions? Spurious emissions are signals generated with a transmitter but not intended to process with a radio with a transmitted circle. The such emissions, of course, include harmonic, but they include parasitic oscillation, signals called inverted positive feedback, various stages in their modulation. What are the key clicks? Theoretical key transistor shall initially stop radiation carrier completely. Over sudden application removal of the power creates rapid surge current with a cause interference on nearby receiver, even though the such receiver with the tune frequency if are removed from that transmitter interference is present form of clicks of thumbs to prevent such interference. Key click filters used with the keying system of radio transmitter. Two type of key filters are shown in figure 4.1. Key capacitors and radio frequency chokes are both circuit with a prevent surge current with a choke coil. Inductor causes lag in current with the key is closed. Current builds up gradually instead of instantly. The capacitor C charges if the key is open and slowly released with the energy stored with the inductor. Magnetic field with the R resistor control with the rate of charge. Discharge of the capacitor also prevents spark with the key contact sudden discharge of the capacitor when the key is closed. Defined the term carrier frequency be a practical value of the radio signal must carry them some of the intelligence supply with the radio signal extending end of the system and remove the utilized receiving end in radio communication systems with the signal of the carrier intelligence high frequency send wave called the carrier wave. The intelligence amplified. The intelligence which is applied to the carrier wave is called the modulation. Can be the form of code, voice, signals, music, or pictures. The intelligence supplied with the carrier is said to be modulated. What is the difference between A0 emissions and A1 emissions? A0 emissions continuous unmodulated pure carrier signal, while A1 is emission continuous wave telegraphed by carrier key. 4.5 standard quality A1 emissions shows radio frequency chokes and to key carried and to keyed circuit. Two types of key click filters. An A1 emission should be free of the chips and keys and clicks and frequency emitted to carrier wave should be constant with the trade with the art permanent to the transfer with the not keyed output various base quality signal prevent spacing wave back wave between coded transmission. What causes a back wave? A back wave is a result of the radio frequency energy leaks through the antenna. Even though the key is open, the effect is on the dots or dashes and similar loud portion of the continuous carrier. It may be difficult to distinguish dots and dashes under such conditions because wave radiation usually results in complete neutralization. Describe some of the more common key methods for the C4 continuous wave A1 transmission. Key transmitter, radio frequency radiated only when the key contacts are closed. The key is open with a transmitter that does not radiate energy. Key is accomplished either with the oscillator amplifier stage of the transmitter. The number of different key systems with the transmitter. Most transmitter and telegraph keys with low potential with respect to the ground keying barring is usually ground to protect the operator key or general key relay, which contacts in the center of the tap of the lead filament transformer used to keep the equipment base because one or more stages of the same filament transfer. These stages are also keyed. Class C final amplifier operated to fixed basis, usually not keyed because of the excitation implied no current flows. Hence, keying final amplifier along with other stages non-oscillator. Oscillator keying. Two methods of oscillator keying are shown in Figure 4.2 with a 4.2a with the grid circuit closed all the time. Key open and closed negative side of the plate circuit with a system called the plating key. Key is open and no plate current can flow and the circuit does not oscillate. Figure 4.2b shows the cathode circuit open with the key is open with neither grid current nor plate current can flow. Both circuits are closed when the key is closed and when the system is called with the cathode key. Although circuits of the Figure 4.2 may be used as key amplifiers, the other keying methods are generally employed because of the larger value of the plate current and the voltage encountered. Two methods of oscillator keying show the plate keying with a plate here and the key over here set between the battery and the capacitor and then return from the induction coil. The other one shows the induction coil capacitors over here, an induction variable capacitor, reduction capacitor, and the key grid and plates and keys. Block grid key. Two methods of the block grid keying shown in Figure 4.3. The key Figure 4.3 shows cathode resistor 1, allowing normal plate current to flow. While the key is open and reduced plate current flows through the through the resistor 1, making the end of the connected grid resistor negative. The resistor 1 is high enough for the base to develop a sufficient to cut off the plate with the current with the depressing when the key short circuit. Resistor 1 increases the bias over the cutoff, allowing the normal flow of the plate to current. Grid resistor is usually a grid leak resistor for the normal bias method. The key is the amplified buffer stage of the transmitter. Block grid keying method shown in Figure 4.3b and 4 for the complete cutoff of the plate current is one of the best methods of key amplifying stage to transmit a voltage divider with the key open in 2/3 of the 1000 volts at 677 volts developed across a 200k resistor. 1/3 of 1000 volts to 333 are developed across a 100k resistor. Grid bias is sum of the negative 100 and negative 333 and negative 433. Because of the below cutoff, no plate current flows with the plate voltage 667 volts current. With the key closed at 100 kilowatts, a resistor with a volt is increased at 1000 volts. The plate with a voltage becomes 1000 volts at the same time with the grid bias between the negative 100 volt grid bias now cut off the amplified triode conducts now the amplifier action follows. When the great frequency stability is required, the oscillator should remain operational continuously while the transmitter is in use. The procedure keeps the oscillator tube with a normal operating temperature. Offers less chance of frequency variation to occur each time when the key is closed. The oscillator to operate with a continuous key is accomplished. The amplifier stage calling oscillator circuit must be carefully shielded to prevent radiation interference with the operator with the receiver and keying relays. And transmitter with the crystal control of the oscillator with the keying is almost for the stage following the oscillator. The large transmitter, 75 watts or higher, with the ordinary hand key cannot accommodate plate current without excessive arcing. Moreover, because of the high plate potential, it's a dangerous to operate with a hand key plate circuit. A slight slips of the hand below the key knob might result in a bad shock. In this case, the defect of the radio frequency plate chokes, so the radio frequency burnout might be occurred. Two methods of block grid keying shows battery, two resistors, 100 and 200 kilo ohms, 100 volt. Your grid and across the grid resistor, key across the resistor grid. Shows typical relay operating keyed system. Induction coil, battery key, relay power, relay, key to ground. And these large transmitters show the local voltage supply, such as the battery filament and supply transmitter. You have the hand key open and closed circuit with a coil with the key relating relay contacts are an open and closed with the key and circuit with the amplifier schematic diagram. Typically, relay operating key and system shown Figure 4.4. Hand key closed circuits with a low voltage supply through with the coil L with the key with a relay armature moved against the tension of the spring with the hand key is open. The relay K is de-energized. Springs open with the relay contents. The symbol A1 designates the purity of the emission. emissions, the readability of the signal, the power level of emissions, the stability of the emission, type of emissions from a radio transmitter, and that is answer E. Now we move on to Chapter 5, Radio Wave Propagation.